Good evening, everybody, or good morning if you're an American. Happy to have you today. We have a very exciting session with Dharani. Did I say your name right, Dharani?
It's
Hopefully, yes.
Dharani Sowndharya.
Dharani. Okay, I was close.
Yep.
Really excited to have you. We're going to be talking about Terraform and AI and the very cool things that you can do with it and how you can do it correctly. Some of the conversation we were having backstage. So I'm actually going to get out of the way for all of it today. I'm going to hand it over and let's have a great session. Again, thank you everybody for joining us. And I will be secretly hiding off stage.
Cool. Thank you, Alan. And let me start by quickly introducing myself. I am Dharani Sowndharya. I am a lead DevOps engineer, and I'm currently working in Equal Experts. And I have an overall experience of almost 10 plus years, out of which these past 8 years I've worked on various cloud and cloud related technologies. I have experience working in multiple data center migrations, data platform setup, and working in multiple finance-based clients. And currently, I'm working in a stock trading client where we are kind of setting up their ledger service. So that's about me. And hopefully, you are able to see the screen. Alan, is the screen visible on your end?
Yes, the screen is good. We are all set.
Cool. Thank you. Thank you for that confirmation. So the topic that we are going to see today is building battle-ready Terraform test suite with AI in minutes. So the idea is Terraform has a test suite, and we'll go in a little bit detail about what exactly that does and how we can use it, and how AI can make your life easier. But before we dive into the whole thing, right, I want to have a conversation where, or have a discussion where we just know why we need the testing actually. So if you see, currently, if we do not have a testing framework in place, what would happen? The thing is, if you have already have an experience of running your infrastructure as a code using Terraform, you will know that without testing in place, you have to run your Terraform apply, and then maybe in your dev environment or maybe your beta environment, where you run your Terraform plan and apply, and then you identify if there are any issues. The problem with that is, if it's a simple architecture, it's straightforward. But let's say if it's a complex architecture, you basically have to eyeball each and every output and make sure that what you're intending to change is what is getting changed. So this becomes a problem because, we are humans at the end of the day. We are prone to error. It is bound to happen. So that is where the job of a DevOps engineer or a site reliability engineer or a developer comes into picture, where we want to automate it as much as possible so that something like that doesn't happen, so that a human error can be avoided. So that is where testing becomes very, very important in case of whatever technology that you use, whatever language that you use, and very important in case of Terraform, where actual infrastructures get deleted if, let's say, you miss a single, maybe a single variable or a single command. So the confidence, you need testing in place for you to build confidence on your infrastructure. And something that I just talked about, just Terraform apply. If you do a Terraform apply and check for the output, it is very risky. And there are a lot of testing frameworks. For example, one of the most popular testing framework is Test, which is written in Go. You have a lot of static testing tools. You have Kitchen, you have your Checo, you have TFLint, a lot of static testing tools are there. But the problem with the static testing tools or any of the external testing tool is, for example, let's say Terraform releases a new version. Let's say 1.14.0 is the current version at the moment. I think it's in beta. So let's say they release a new version 1.15.0, and you have something cool in there and you want to use it. But you have to make sure that all of these additional tools should also support whatever version the Terraform is running in. The problem with this is that we have to wait for, let's say, your external tool to also update to the recent version that Terraform comes with. And thus, this way, you are kind of dependent on another tool. And let's say they make some mistakes, they have some bugs in their framework. Then you have to go and raise a PR. If it's an open source tool, you have to go and raise a PR. And it becomes a complicated process altogether. So that is where Terraform testing comes into picture, and particularly the Terraform test command that was released by the Terraform folks around version 1.6.0. This is kind of a very simplified timeline of the testing features that was released in Terraform. If you consider version 0.13.0, that is where the input variable validations came into picture. And if you can see, I have a YouTube link at the bottom. So this kind of is a talk that I gave an almost an year back, where it covers each of these functionalities in detail. So when we share the slides, do check it out. And if you are new to Terraform testing, I'd highly recommend you folks to go through this video. It has detailed information about everything from input variable validation, precondition, postcondition, checks, and also Terraform test. Okay, so if you see, version 0.13.0 gave input variable validation, 15.0 was where they released the experimental test command, and eventually around version 1.6.0 we got the actual Terraform test command. This was around 2024, 2025, early 2024, I would say. So during this time, it was very brand new, right? A lot of people did not know that this was available. And from then to now, even from the time of the talk, when I was preparing for this talk, there were barely one or two videos throughout YouTube that explained how a Terraform test command works. But now you can see a lot of documentation on it. A lot of people are experimenting with it, and a lot of features are coming into picture. So the current version right now is version 1.14.0 beta 2, and till now we have a lot of enhancements that came in that will make your Terraform test experience, how can I say, very easy when compared to, let's say, when it was in the beginning stages. So why you might have a question, why should I use Terraform test? You know what, I use something like a Terra test or my own test suite package. Why should I use Terraform test? What advantage do I get from it? So the main advantage is that it creates real infrastructure, and it is baked in the format or the way in which the code is written. So it creates actual real infrastructure, and as a result you will be able to do real world testing. And for example, usually when you want to, if you are someone who have used Terraform, right, what will you do is, once you've made some changes in Terraform, you run a Terraform plan in your local and probably a Terraform apply against your beta or dev account, right? So that is kind of inbuilt here. You don't have to run Terraform plan and apply. The code part of it takes care of whether you want to plan or apply it. And I'll quickly cover how a run block of a test condition looks like. But it gives you some kind of an automation around it. So it is simpler for you. And the third thing, the reason Terraform became so popular over other tools, and it's kind of leading in the IAC market, is because of its declarative syntax, which means that you don't have to give it imperative commands like, you know what, go and create this EC2 instance. But before creating EC2 instance, create a security group, create an IAM role, and then go and create an EC2 instance. This is what we call as an imperative command. In case of Terraform, what we get is declarative commands. It basically says, I need an EC2, it should be T3 micro. That should be a security group. These are the ingress and the egress that should be opened. And let's say this is the IAM role, these are the permissions. That's it. Terraform's syntax and the way Terraform is built is, it will identify a graph between them, and then it will be able to identify the dependencies, most of the dependencies. Some of them it won't be able to. That's where we use something like a depends on attribute. But most of them it will be able to identify, and it will be able to give you the output that you desire. So that makes Terraform very, very powerful and also easy to learn. And also, this is what it made it popular. And this Terraform test command, you don't have to learn a new language. You don't have to learn Go, even though it's nice learning a new language. But let's say you are compressed on time, you have to deliver production ready infrastructure as soon as possible, right? In that case, you don't have to go and learn a new language. Like in case of kitchen, I think you have to learn Ruby, which is a new language altogether. If you depend on external tools, then you are dependent also on learning all of these languages that these tools are written in. Whereas in case of Terraform test, right, it uses the same language, which is HCL, and so the flow is easy. You will be able to understand it easier as well. So this is how a typical run block. This is a very simplified run block, but you will see different types of run blocks when we are generating via AI. But this is how a very simple run block looks like. I'll explain this for people who do not know Terraform test. This is how it will look like. Think of run block as kind of like logical block in which all of your test cases, assert statements can be written. Not all of your test cases, but more like assert statements can be written. You can give some logical name. Like if you work with Terraform, you also know this, right? Usually we'll give, let's say if it's AWS, the actual AWS resource name, and then some logical name that you give for it. Similarly, run, and then you can give some logical name here, whatever makes sense for the test, and command equal to apply. This is what I mentioned a little bit earlier. The plan and apply is kind of baked in. By default, it's command equal to apply. If you give command equal to plan, it will run just the plan. So you might get a question, where should I run plan? Where should I run apply? So you should run plan when you want to just test the logic of your code. Whereas if you have to run apply, if you want to, let's say, test against the output that it generates. Let's say in this example, right, it is basically testing whether the EC2 instance type, upon apply, we'll be able to know whether the EC2 instance type that got created is T3 micro or not. Let's say there is a condition that where in case of a test environment, you do not want anything other than T3 micro. You do not want an M5 or a higher level instance, you can add this test. It would make sense there. So this is how a typical run block will look like. So, and Terraform test architecture. So again, for people who do not know or is new to Terraform test, I'll give you a quick understanding about how the architecture looks like. So if you worked in Terraform, you know that all of the Terraform code resides in .tf files. In case of the Terraform test files, it will be residing in .tftest.hcl files. So I'll be able to quickly show you some of the examples. For example, if you can see here, this is one of the test files that is generated. And as you can see, it resides within .tftest.hcl as the extension. And whatever resources I mentioned that as part of this, one second. Yeah. So as part of this, I mentioned that it creates actual infrastructure. Then you might get a question, what if it kind of, messes up with my actual infrastructure? I have my actual infrastructure that gets created by .tf files. What if the Terraform test, whatever infrastructure that gets created by the Terraform test messes up with that? We do not want that, right? So in order to avoid that, it keeps the state in memory. It is completely separate from the live infrastructure. You don't have to worry about it messing up with your actual infrastructure state files. And it can create real infrastructure for validation. And again, if you use command equal to plan, it won't create actual infrastructure. And once done, you don't have to give a Terraform destroy. What will happen is that in this case, right, once this, let's say if the test file just has this one Terraform, one run block, what will happen is that it will go ahead, create the infrastructure because we have command equal to apply. It will test against this condition. And once this condition is done, it will automatically delete the infrastructure or destroy the infrastructure. So it automatically destroys the infrastructure. Again, default behavior, by default, if you do not specify anything, it's apply by default, or else it is command equal to plan. Cool. This is what we saw. And a typical Terraform file structure will have something like a variables block. You can also test modules using Terraform test, and you can also organize these files inside a separate test folder. And as you can see here, I've shown this, like let's say EC2 is the Terraform code for which you are generating tests. You can you will put all of the tftest.hcl files inside a test folder, and when you run Terraform test command, it will be automatically able to identify these files and it can run Terraform test commands for you. Cool. So Terraform test mocks were introduced in version 1.7.0. This is very important because we all know it's not like when you run test cases for a language like Terraform, right? It's not very similar to, let's say, what you write in Python or Java or any other language. Reason being, it actually creates infrastructure. Consider this, right? If you have used AWS and let's say your infrastructure creates, let's say, a service like RDS, usually it takes 20 minutes for the service to come up and to get into an available state. So let's say for my testing purpose, I don't want to create an RDS every single time. I just want to create it once, but for the other use cases, I just want to test the logic around it. Then there is a way for me to mock it as well. This will reduce the time taken for testing your resources significantly. And you can mock providers as well. When I say mock providers, what does it mean is that usually when you are running your Terraform code, you use something called as an AWS provider. This is responsible for getting your credentials from your local and then connecting to, let's say, your AWS console and then AWS APIs and then doing some operations on that. But let's say I don't want to do that. Just want to, test the logic of my application. Then I can mock the provider itself, which will what will happen is that it won't even connect to the AWS provider, but instead it will mock the return values, and you will be able to test the logic in a few seconds. This is a huge advantage. Similar fashion, you can also mock resources, you can mock data, and you can also mock a specific module itself. Let's say you have an application that has like 5 module dependencies and you don't want to test each and every single thing. You just have to test one module, so keep the first only one module and the rest of the modules you can mock them. So this reduces the time taken to a significant level. Again, for people who do not know Terraform test, it might look really overwhelming, but whatever I've explained, it is covered in this YouTube video. So I highly recommend you folks to go and watch it before watching this video in that case. Cool. And while working with Terraform test, these were the key insights and learnings that I had. I just wanted to share it. Infrastructure is created and destroyed per tf_test.hcl file, which means that you saw a run block, right? A tf_test.hcl file can have multiple run blocks in it. So infrastructure is not created per run block, but it is created per file. So plan your placement of the tests in such a way that it does not create too many. For example, in tf_test.hcl file, in one file, I logically place a lot of run blocks so that the infrastructure gets created, all the assert statements are tested against it, and then infrastructure is deleted after it's done. So if you split it into, let's say, 10 to 20 files, what will happen is for each of the file, it is created and destroyed individually, which will significantly increase the time of execution of the tests. And asset blocks run, Terraform plan and apply underneath, creating full infrastructure. Module support, you can mock the module. State management, it does not have a single state file. Unlike Terraform, right? If you're using Terraform tf.tf files in a single project, what will happen is it will create one tf state file. But here it will create multiple state files that you don't have to manage. Terraform command itself will be able to manage all of them. So this is about the key insights and learnings. So now we come to the bread and butter of this topic, which is how can we make this all easier? Can I use AI? So for people who are new to this, right, it will be a little bit overwhelming. What should I write test cases for? What are the situations in which I have to write test cases? What are all the conditions for which I have to write them? What can I skip? What can I create? And now we use AI for almost every single thing out there, right? Can I use AI in order to solve this? Can I make my life easier by using AI? Yes, it is possible, but there is a condition. The reason being, it is possible with an MCP. For people who do not know what an MCP is, I'll touch upon it in a minute, but it is possible with an MCP. How we have done this for our demo is by creating an MCP, and we have integrated it with Claude Code and Claude Desktop. So Claude is one of the tools using which you can connect to the Anthropic models. Similarly, there are multiple tools, but for this use case and for this demo, we are going to work with Claude Code and Claude Desktop. Next question. You might have a question. Oh, you are seeing a new term, MCP. Why should I even use MCP? You know what? I'm already using, let's say, GitHub Copilot. I'm using Cursor AI. I'm using maybe even Gemini, and then I'm just feeding my project to it, and it's giving me the right solution. I don't have to worry about anything. Why should I use MCP? So you might have that question. So the answer for that is this is relatively new. There is not a lot of documentation on Terraform test, or not a lot of examples that you can find online. As you know, AI models are trained by the data that it finds online. Since it does not have the correct data, or how can I say, relevant data, it is not yet trained to be accurate about how to generate test cases. So it does not know. Like if you just go to your AI model and ask it to generate Terraform test cases, right, it will give you a lot of wrong answers. And that is where I have written this MCP where it interacts with a certain method or a certain way so that it produces more accurate results. I wouldn't say 100%. The accuracy is still low. We'll touch upon the accuracy in a minute when we show the demo. I would say it's around 85 to 90% now, but it's not 100%. But even for this 85 to 90%, I had to use something like an MCP where it is able to read some content and data to generate it at the correct way. Okay, I'm mentioning a lot of MCP and all that. Let me touch upon what an MCP is. MCP is nothing but Model Context Protocol. It's just a protocol that is written in so that it is a way for connecting AI models to the external tools. For example, if you want to connect your AI model to, let's say, Jira or your GitHub repo or your GitLab repo or even your file system, right? You need some way in which the connectivity can happen, right? So the MCP serves as the mediator between these two. We can write something called as an MCP server that will give that capability to your AI model. So why an MCP? Because this is an open standard, right? This gives us a standard way for us to write our service so that we get a standard output. So this will reduce, for example, if an MCP is not there, if a standard way is not there, everyone will write. For example, if I want to connect my AI model to Jira, I'll write my own set of code. And if I want to connect to GitLab, it will be in a different format. Maybe I'll write in Python, maybe I'll write in a different language. But having something like a protocol helps me to have a similar, or how can I say, a standard for how you connect to the external tools. It is a client server architecture. It enables real world AI agent actions with reduced hallucinations. So, like I said, it's a clear example, right? If I do not have an MCP for this use case, which is Terraform test writing, what it will do is it won't know because it is not trained enough with relevant examples. It will just give you some hallucinated data that are just page fillers. So to avoid that, we need something like an MCP. Can I use it only with Claude? No. You can use it with any of the tools that supports MCP. For example, Cursor AI, GitHub Copilot, if you are running it in VS Code, Klein, Windsurf, you can use this MCP with all of these AI tools. Okay. Why Claude Desktop, Claude Code? It has several advantages. It has multi-modal access, which meaning it can understand image, it can understand text, and it will be able to understand, like let's say if I upload a PDF or a screenshot or image, it will be able to understand it and it will be able to give me a really neat output. And it has nice file system integration using the MCP service, and it gives me a secure interaction with local computer resources. And that's why I chose the tool Claude Desktop or Claude Code. Okay. The current MCP setup and architecture that we have is, let's say user, that would be you and me, right? We provide the folder path where the Terraform files are located at. Now I give it to the MCP. MCP, I have written an MCP in such a way that it is kind of like a prompt generator. I'll explain what I mean by that. So basically, it will just validate the path. It will load the prompt template, which I've written. I'll show you in a minute. And it returns a prompt by substituting the values that it found from this folder path. And then it supplies that to Claude Code again. Why supplies back to Claude Code? Why not MCP take care of generating the files itself? The reason being, I've tried that approach as well, meaning the MCP itself, instead of writing it to Claude Code and asking Claude Code to generate, can I write a program that generates the test cases? Honestly, it is confusing. It will be confusing for new users. It will get complicated and it will be error prone because we have to. It is not straightforward, right? Writing test cases is completely dependent upon what you are supplying to the MCP, and there are hundreds of resources available. You can't test every condition, so that did not work. So supplying the prompt back to Claude Code with, how can I say, augmented information that will help Claude Code gave relatively better output when compared to writing my own MCP server with a lot of Python code. I wrote my MCP in Python with a lot of Python code that did a lot of things, right? But when I supplied the prompt with all the augmented information to Claude Code, it performed better. So now Claude Code, it reads the Terraform code from the user request, it analyzes it, it follows the guide that I've provided in my prompt template, and then it generates test file. It creates the test folder and then it writes the files in the test folder. So this is how we've written our MCP setup and architecture. Okay, enough of theory, right? We had a lot of theory. Let's go ahead and then look into the demo part. So before we start, what I'll do is I'll explain this all of this in a minute. What I'm doing is, since it takes some time, I'm provided that I've kept it ready. I'll explain what's this every single thing I'll explain, but I've kept it ready. Let me go ahead and then give it to the Claude so that it performs, it does its job parallelly while we go and explain the concepts. Okay, cool. So let me go to the Terraform Test MCP. This is the MCP that I've written. And this is the template that I was talking about, which is your prompt template MD. So the prompt template MD, this is not, how would I say, is not a one-time generated task, right? I didn't go to Claude and asked it to generate a prompt for me. Rather, it was more of a trial and error process that went on for a while. And the advantage is that now you don't have to go through this. All of this I pushed in a GitHub repo. All you can do is just pull it and then you can run your MCP and you will get all of the work that I've done. And that is the advantage of an MCP as well, right? You don't have to worry about understanding it and doing it. All you have to do is just pull my code and then add that MCP to your AI tool, and you will be given how can I say a semi accurate AI generation for test suite in a few minutes, right? So as I'll just quickly explain, I'm not going to go into detail. As you can see, it's a long file. You can see the scroll all the way at the top, right? It has a checklist that it generates that it needs to check. And as part of step 1, it gets some mandatory user information. And part of step 2, it analyzes the code. Step 3, it starts generating your unit test, integration test, and mock test. It also generates a coverage report and a README documentation. And then step 4 goes into detail of comprehensive syntax examples. So I came with this how can I say section because it generated a lot of hallucinated outputs even despite me providing all of the necessary resources. So to avoid that, let's say if it generated a wrong output, I just copied it, gave it as a bad example, and how to correct it. What is the correct way? In a similar fashion, for a lot of the use cases, as you can see, I've given a lot of examples, the right examples and the wrong examples, so that it can go through them and then find the right value for them. Just give me a second. So this is how it works, and a lot of examples. I let you folks go through it when you have some time. So it has a lot of examples. All of them came from a lot of trial and error. And once done, the next step is list of, so okay, now I've told what, this is a good example, this is a bad example. Now it will get confused. It'll ask me, okay, you tell me what I have to generate. So this step has valid test cases that it can generate, some generic examples of valid test cases that it can generate. And the next step is, yeah, step 6, how the logic table for that, which is a command to select for what, when should I use plan, when should I use apply, and some best practices checklist. And finally, once you are done with all of that and gone through all of that, you have to go through the step 8, which is a mandatory completion checklist, which basically checks against whether it followed all of the approaches, whether it generated it in the right way. So this is my prompt template. And main.py, it might look like a big file, but it is pretty straightforward. What it does is it loads the prompt template.md and feeds it back to Claude and asks it to generate the test cases. That is the sole purpose of this main.py. As you can see, I also have written a Docker file and a Docker compose. This is kind of an experiment that I'm still trying to figure it out. So basically, I'm trying to package all of this in a Docker so that you will have an advantage of running this MCP irrespective of the OS that you are running in. But unfortunately, I was not able to make it work. There were some, how can I say, complications in the implementation. But if I figure it out, I'll definitely push it to the GitHub repo. I'll be sharing the link at the end of the slides. You can go through there and then check that. So this is my Terraform test MCP. It's pretty straightforward. It loads a prompt template and then it supplies it to the Claude code. Cool. In the meantime, yeah. So Claude Code prompt, I've also documented the prompt that I should give to the Claude Code. This is what you saw me copy and paste here. And as you can see here, whatever I copied, I had substituted the values for, let's say, saving some time. So this is how this is kind of again a lot of trial and error I went through. And even though I gave very exhaustive list of examples, good examples and bad examples, I got a lot of errors. And to avoid that, this prompt kind of bug for me, I've again committed this to the Terraform Test MCP repo in my GitHub repository. You can always refer to that. And there I've made sure that, this Claude Code prompt, I've made sure that it follows all of the assert statements. And it's again a bit of a trial and error to make it follow. Would I say that it follows at 100%? No. I would say it still follows 80 to 85%, but it still reduces a lot of time on your plate in generating those test cases. Okay, cool. Cool. Yeah. So now this is about the Terraform test MCP. This is the repo for which we are generating the test cases. As you can see, I've already generated the tests. Let me go ahead and then delete it. This was done for just testing if the demo works or not. But this is my EC2 code. It does nothing. It basically creates an EC2 with a security group. It has provisions for creating an IAM role. It's more or less just a simple EC2. And if you can see variables, I have added some variable validation. This is what I call a variable validation, where you can check whether the variable value is correct or not using some validations. And this is pretty straightforward. Whatever you saw in the variables.tf, and it's a pretty straightforward EC2 instance creation code. So now it's in the process of reading the code and then using the Terraform test MCP to generate the test cases. Let it do its work. So let me go through this prompt a little bit, right? So basically what I'm telling it is generate test cases for the Terraform code present in this particular folder. So it needs some values for testing it, right? For example, if you do not give this tf-vares file, right, it will just randomly take some random values and then use it for testing. I do not want that. So I've just given Terraform tf-vares, because if you have to create actual infrastructure, let's say, or you have to provide the correct region, you have to provide the correct VPC ID. For that reason, I'm giving the Terraform tf-vares reference. I can also add compliance checks. This is again some configuration that I've added in the MCP, but for quicker development or quicker demo, for now I'm skipping the compliance checks for this test generation. But ideally, you can give compliance checks, like for example, make sure through this test cases that my infrastructure always has a environment tag to it or a owner tag to it. And if it does not have an owner tag or an environment tag, it should fail. Ensure that my Terraform EC2 instance security group does not have the ingress open to 0.0.0.0. I have to, if it is open to that, my test case should fail, and whoever is the developer for that code should go and fix it. So you can add compliance checks like that, but for now, for quicker generation, for the purpose of demo, I'm skipping it. Basically, I'm saying use the Terraform test MCP to generate test cases. I'm giving some rules or conditions to it, and I'm asking to based on some of the trial and error, there were some misses, so I've tried to cover them. So that's it. Cool. So now, as part of this command or this prompt that I gave is right, it was able to analyze that this particular Terraform code has EC2 instance security group and all of these, and it is saying what, for unit test plan, it is actually awaiting for my approval. I had configured it in such a way that it should not proceed without awaiting my approval. This needs a man in the middle or woman in the middle. The reason being, it in this case, right, it hallucinates a bit and I don't want it. I don't want rework. So I introduce this, so it is awaiting for my approval. And in this case, what I'm doing is I'm just going through it. Since I know Terraform test, I'm going through it, eyeballing it and saying, okay, I think it's kind of right. Basically, this particular condition, right, what it is basically testing is, if the VPC ID is empty, then it should have gotten the actual VPC default VPC ID, and the length should be 1. If not, if the VPC ID is not empty, it should be 0. The data AWS VPC should not be even accessed. This is one of the logic that I have in the code. Similarly, it has some things I'm good with this, and then it is titled unit locals computation because it is generating. It is all of this is done in a local block, and then it is doing unit conditional resources. And what it is doing is same kind of something similar. Create security group. If the create security group is true, then AWS security group should have been created. And if let's say if it's false, the security group should not have been created. Similarly, it does a few things. I'm eyeballing it. It kind of looks okay. And unit tag merging. So I have a couple of tag related stuff. So it's merging it. And it's basically pausing for my approval. I think it looks good for now. I'll just give looks good. Now what it will do is it will go ahead and then create the test folder inside my EC2 folder. Again, you don't have to do anything. If you follow the MCP, it will automatically go and create this test folder, and it will create these files one by one. Just unit locals computation, and then unit conditional resources, unit tag merging. It will create all of these resources one by one. If you want, you can also go through this, and it is using a mock provider. I mentioned about mock provider, and it is you having a variables block where it's substituting certain values, and it has the conditions which we just saw in the awaiting approval stage. Right, for me it looks good. Things look good. Yeah, okay, this is a typical example of how can I say a failure, right? For example, this is one of the instructions that I gave that it should follow, which is, I'll tell you, for command equal to plan, which means that when you run a Terraform plan, it will not have a view of the data blocks. If you run a Terraform plan, right, for the data blocks, you will get a value, right, values known after apply. That is the value thing that you'll get. But here, as you can see, for command equal to plan, it is assuming the data blocks will be available. So sometimes it makes these errors. And what you can do is you can just go and tell it, at the time of plan, data blocks will not be available. Can you change it? So what this does internally is that it will be able to understand, because I've provided that instruction in the prompt template.md, and it will edit the test case in such a way that that does not happen. Let's give it a few seconds. Yeah. So as you can see, you're absolutely right. Data source are not available during command equal to plan. So it is able to all assert statements, line by line validation, and then it is trying to find the fix. And line by line uses command and test actual logic, not just variable values, no resource data source access. Okay, I think now it looks okay. Let me see. Yes, please. So what it is basically saying is, shall I move this resource creation to integration test rather than unit test? Unit test is basically command equal to plan related test, and integration test is command equal to apply test. It's basically saying, and move the conditional resource creation to integration. I told yes, and it's continuing. So it takes a few minutes here and there, and then let's see if it fixed the issue. Yes, for example, if we take this example, right, it is command equal to plan and allowed HTTP cider blocks. There is an expect failures block. Again, if you know Terraform test, this is an assert statement. It's a negative assert statement, which means that if I give an invalid value and I have a variable validation for this, let's go to the variables.tf. Yeah. So what the condition that I've kept is it should be a cider block. Here, as you can see, it's an IP. It's not a cider block. So what will happen if I supply this value is this variable validation would fail and the Terraform plan would fail. So it is expecting failures. And if a failure happens, that means that assert statement, that particular statement is true. So that is what this assert statement is doing. Again, this is kind of configured in your code, the MCP, so you don't have to worry. So it's done some, because I have a bunch of variable validations, it has done a lot of assert statements. So just eyeballed it, looks good. So let's see and go to the tests folder. As you can see, the unit variable validations are created. It will continue to create the other files in a similar fashion. It takes a few minutes. Yeah. Now we are back to, as you can see, it has fixed it. Previously, it used to be data. It was referring to the data variables. And since we pointed it out, fixed it. This is your unit tag merging. I do not see any values, any problems right away. So let me, for the time's sake, usually I spend a little more time, but for time's sake for this demo, I'll just give S and it will go to the integration test. But what I'm trying to say here is that don't unlike for example, let's say if you're by using it against your Python or Java code, right? You can expect it to be a little bit more clever. How can I say this? It will be much more smarter because it is trained in the data a lot, and you can trust it to a certain extent. But in case of Terraform, there is a little, since it's not trained in the data, it generates random stuff here and there. To avoid that, we've created this MCP, but still there'll be like I said, it's 85 to 90% accurate. So the 10% you have to be a little bit more careful and just go through the output that it generates and make sure that it is right. So I'm saying, yeah, it can proceed with the integration test files. It should have created 2 files. It will create an integration test file. For the time commitment or time being, I'll stop at integration test file. I'm not going to go with mock files, but yeah, let's see. Let's give this a shot. And yeah, command equal to apply for the integration test, and it testing whether whatever tags it is applying had come together, and it's making sure that if I set the root volume as a variable as 50, whatever instance that got created has that volume set. And similarly, is it encrypted true? Was it able to pick up the variable? Was the substitution proper? Yes, I think it looks good. So next, it's trying to generate mock tests with override patterns. So let it complete that step. And in the meantime, what I'm going to do is I'll just show you folks how it looks. So this is your basic tfTest.html. You have a variables block where you can define the values, and using run blocks is how it can assert the statements. And as you can see, it has a lot of assert statements probably for each of these variables. And test EC2 with monitoring, and it covers a lot of stuff. EC2 different instance type, larger root volume, EC2 GPT volume, and it's up to you, right? If you feel like it's missing something, you can ask it to create it for you. And one important tip that I want to share is, let's say you find something, you already created it, you find something wrong in this file, do not go and edit it manually. Do not go and, let's say, put an assert block here or edit an assert block that it created. When you do that, right, the accuracy drops to a very low level. Instead, if you see some error, if you see some issue, just copy that part and then paste it back into the Terraform, paste it back into the Claude itself and ask it to correct that error. For example, let's say it has tested this name, right? Let's say if it's wrong, it has tested something like ABCD, which is not even there. You can just copy that value and then give it to Claude Code and ask it to correct that error. And that way, in the next time that error pops up, right, it will be able to have that in that session. If you are doing it in the same session, it will be able to have that in the memory, and it will be able to make corrections. Let's say you have generated multiple files, right? So if you are generating multiple files, it will edit all of these files, and you don't have to manually go and make this change in each and every file. It saves you a lot of time. As you can see, it has generated a lot of nice integrated EC2 basic IAM profile outputs, and it's generating the mock test with override patterns. Let it generate. So another important thing is that it does not do the same thing twice. That is something of a learning as well. Let's say this, I had copied the previous test that I generated just maybe an hour before the demo. I just wanted to test, and as you can see, it generated just 4 files: your integration, mock, unit, configuration, unit variable. And as you can see in the current session, right, it has generated almost 6 files, and it's still generating some other files like mock. So it does not recreate or replicate it exactly. It creates a different set of, how can I say, values, or files each and every single time. Choose the one. For example, let's say the first time it generated, you feel like it's not, the coverage is not that good. You can definitely put it in the Claude Code prompt and ask it to cover more areas, or you can give examples like, what, this is missing. You can cover it, or you can even be like, what, I don't want an individual test file like this. Instead, convert or converge all of them into a single integration test. So you can do that. So yeah. So all the tests are generated. So as part of the MCP as well itself, I am also generating something called as a coverage report. So this coverage report will tell me what part of the code is covered. Usually, when you are, let's say, take an example of Python, right? You will be able to run it against certain static tools, and you will be able to understand how much part of the code is covered, what is missing. So I wanted a similar feature, but that is not available as a plugin or something like that, but something that the Claude itself will be able to generate. It will be able to go through the TF files, and it will be able to give me a coverage report which says, what, this part of the code is covered. IAM instance creation is covered, security group is covered, whereas IAM role creation is not covered. So this will give me an idea, so that the next time I'm generating test cases, I can just supply this coverage report that it's generating, and it will just generate the coverage report, and I can tell it that, what, you covered, like say 90% of this, but 10% is not covered. Can you write test cases for the 10% that is just not covered? So I can do that, and that is what is happening. So it is trying to create a coverage report, and also it will create as part of the MCP as well, it will create a nice readme.md, so that it makes sense. Like, it will give you an input into what are all the different tests that you have, how can you run these tests in your local. So all of that will be given into readme.md. All of this is generated because I've given the format for this readme.md. I've given the format for this coverage report. Let me go to the coverage report. Right? So I've given the format that I should have a markdown table with these columns that tells me what should be covered. And I should have readme documentation. It should have test suite, execution instruction, directory structure explanation. And it does a wonderful, honestly, it does a wonderful job. Let's wait for a few seconds before it generates the coverage report as well as the readme docs. Just a second. Yep. So, and that is one of the use cases, right? You can, by getting this coverage report and the readme, you can supply that as well as a memory or a session context to the next run that you are having. And using that, it will be able to identify, because, the best for your AI model is the model itself. So you can provide these MD files for it to have that context, and it will be able to continue or make changes or even edits to the existing content. So it has created the coverage report. Let's open the coverage report. Yep. Let me open the preview for it. And as you can see, it gives me a very nice summary statistics. It has, for out of the total resources, all of them are covered, what is missing, and for example, what is the coverage percentage, and what is missing is also will be covered. For example, I think it's been really good, 100%. Take it with a pinch of salt though. If it says 100%, it need not be 100%. You can do a double check, and you can even ask Claude, what, you told user data as 75%, but actually it is not, because this case is not covered. It will go ahead and then make the correction and then come back and update the values as well. But it's, I would say, again, 80 to 85% is what I could achieve. But maybe this GitHub repo is public. You folks can play around with it. You can make changes to the prompt template and see if you can achieve more accuracy. And obviously, once people start using this a lot, Terraform test a lot, you will find a lot of examples online, and the AI model gets trained, and obviously our accuracy will become better. But for now, take it with a pinch of salt. So it gives me what are the tests that it had written, what are the files for each of these tests and mock tests, and what is the distribution of these tests, like how many tests in each of this, and how coverage by test compliance security testing. By now readme.md is also ready, and recommendations. It gives a nice format, and readme.md is also ready. And again, let me open the preview for this. And as you can see, it gives you overview, prerequisites, what is needed for this to run, directory structure, the types of tests, and how to run these tests. For example, if I just want to run, let's say, one of these files and not all of them, I can use a filter, and it gives you this wonderful, where is this getting all of this from? Again, from the prompt template.md. So Like as you can see, I've given specific documentation references, primary reference for Terraform, general Terraform syntax, Terraform testing documentation, how to use mocks, override patterns, Terraform test command use case. And this is where it gets all of this detail, and that is how it populates the readme.md. And as you can see here, it has this nice directory structure, running tests, and all of the stuff is covered. And it is pretty detailed. It's pretty good with all of the stuff. So it's almost done. I'm not sure what it is trying to do. And I think it's trying to generate a summary. It is saying it went through the step right, which is mandatory completion checklist. It is making sure that all of that is followed, and it is trying to basically list some files, and we are good. So yeah, I know it took a few minutes than promised, but eventually, like for example, if you become comfortable with it and you do not have to manually go and press an S every single time, it would have generated all of this in barely 7 to 8 minutes. I tried that, and you would have gotten a full test suite that tests all of your infrastructure along with a coverage report and readme.md in close to 7 to 8 minutes. So, due to the lack of time, I'm not sure if I can run Terraform test on top of this, but let me try at least one thing, right? Terraform, let me use a filter command and see if I can run Terraform, because we have integration test and it takes forever, right? So, you can even use this filter command, right? Filter equal to tests. I just want to write, let's say, unit tag merging. Let me copy this. Yep. Let's see. It'll fail. I'm not saying it all of that will pass. Sometimes it'll pass, sometimes it'll fail. And if it fails, I'll tell you what we have to do. If it passes, we are good. But if it fails, I'll tell you what we have to do. So I'm running my Terraform test against this unit tag merging, and it's basically running your test cases one after the other. And I think today is our lucky day. We are getting passes. Let's see if one of them fails, I'll tell you what we can do. Cool. All of them passed. Let me try a different file, which is unit variable validations, perhaps. Yeah, it failed. So invalid operand, you unsuitable value for left operand. If something like this is failing, right, like I said, do not go and edit it, copy it, and just feed it back to the Claude code. Now it will be able to go, because it has all the details, right? In this file, line number 70, it is a value that is error. So it is going to fix it automatically for you. You don't have to do manually anything. So now it's basically testing. Let's see. Okay, let's see if that fixed that particular error. The error was test instance name too long. Let's see. Yeah, test instance name too long was a pass. So probably if you see that, right, it was using some operand that was not supported. So instead of having a very long name into 30 or something like that, basically it would have generated something like very long name into 30, like 30 times very long name. It generated an actual value, and it is a pass. So this is how you can edit the test cases for your use case and then make it work. But that's about it. So you have in your hands a battle ready Terraform test suite that got generated within a few minutes. So I had a few learnings while playing around with AI. Let me share them quickly. Sometimes it is too eager to please. What do I mean by that? It means that it generates literal page fillers. For example, it'll have a variable block. In that variable block, it'll have something like environment equal to test. And in the assert block, it'll test whether that environment is equal to test. So if you set a variable and test it, it will always be true. So it is too eager to please. It skips instructions. As you can see, even during our implementation, right, I had given a specific instruction for that. Only for apply, the computed resource should be checked. But despite that, it kind of did a page filler thing. But for plan, it generated this data check against data block, right, which will not be available. So it generates page filler content. It is too eager to please you, so you have to be the person in the middle who tells that, you know what, this is wrong, this is right. You have to keep an eye out on how the output comes. And this is something that is interesting, since it does not have a lot of data, right? Sometimes I was wrong. For example, some use cases I was wrong, but I told, you know what, I think you generated it wrongly, and it told sorry, and it corrected it. There was a proper test case that was running, but it made a mistake and while correcting it, right? So sometimes it says sorry even if it's not wrong. So it is not analyzing it further. There are some caveats there. Again, you have to be a little bit more mindful of what it is creating and then check it out. And this is the most important thing. All of this Terraform test MCP, this output did not come in a single day. I think it was a period of 3 to 4 months where I tested with multiple projects, multiple resources, multiple formats for me to get a sort of a template that works to 80 to 85% accuracy. So it needed a lot of iterations to get it right, and it is not yet trained for the specific bug, and you definitely need a lot of patience. And finally, and this is a personal recommendation, take it or leave it. When I get really frustrated, I just, name it ma'am or dude. You know what, ma'am, you're not giving it right. Or, dude, whatever you are giving is wrong. I am very frustrated with it. And it kind of makes the whole process easier. Again, it's a personal recommendation. And maybe, if one day this AI becomes the ruler of the world, right, we'll be maybe for being kind to it, for saying thank you, for saying please. Maybe it may remember and spare us our lives or dignity. I don't know. So yeah, that's about it. Thank you. And whatever code, whatever Terraform test MCP, it's there in this GitHub repo. And I have my LinkedIn. You can always reach out to me for any questions. For any questions, you can always post as a comment in this YouTube video, and I'll be ready to answer, happy to answer. And tomorrow, I'll spend some time in writing a blog about whatever was part of this call, so that you folks will have a written reference to, so that you don't have to go through the whole video for you to get some certain facts right. So I'll be doing that, and I'll be publishing it in my same name, dharani.sowndharya.medium.com. You can always reach out to that. Well, that's about it. Thank you. I think we are on time, just 3 minutes more. Over to you, Alan.
There we go. I was on mute. That was amazing. Thank you. Thank you so much. This was a wonderful session. I normally ask people at the end, what's the best way to get a hold of you? You've already said LinkedIn and already gave us the link. I have no questions because that was wonderful. That was all my questions have been answered. I I think we're good. Is there anything else that you wanted people to take away with, just like a one sentence summary?
Definitely. So I'm kind of also working on making this into a package so that it removes the dependency on your OS. So once that is done, I'll definitely post it as a blog or even in my GitHub repo. So you folks can just use it like a, let's say, pip install Terraform test MCP, and you should be able to use it. So that will make your life even more easier.
Amazing. We'll be sure to link to that whenever that's available. We'll put it on the
Sure.
description of this video. So
Cool. Thank you.
thank you very much. This was great. And we will see you next time. Thank you.
Cool. Thank you for the opportunity, Alan. Thank you, folks. Bye.
Absolutely.